Welcome to this tutorial. In this tutorial video, we want to look at how we calculate or how we found the enthalpy change when we have been given certain information regarding the overall reaction. Now, when you have been given such a question, we use what we call the Hess's law. We want to remind ourselves what the Hess's law says. Hess's law helps us to understand that the enthalpy change of the overall reaction is equal to the sum of the enthalpy changes of individual steps. So let's see how we apply that knowledge in this video. The question reads, given the enthalpy changes for the following reactions. So we have the first reaction where carbon is reacting with oxygen to produce carbon monoxide and oxygen. The enthalpy change of this one is negative 110 joules. Then we have the second reaction where carbon is reacting with oxygen to produce carbon dioxide. The enthalpy change of this reaction is negative 394 joules. So the question is now, what is the enthalpy change for the reaction where carbon monoxide is reacting with oxygen to produce carbon dioxide? So when you look at the question that we have been given, we need to look at what we have been given as the reactants and as the products. So when you look at what we have been given as the reactants and as the products, you now look at what do you have in terms of the two equations that we have that can help you to come up with this overall reaction. Now you'll notice that we have carbon monoxide here and oxygen. So in which equations are we finding carbon monoxide and oxygen? You'll notice that in equation 1, that's where we have carbon monoxide and oxygen. Now in this equation, carbon monoxide and oxygen is on the product part, while we have carbon and oxygen as reactants. So when we are involving Hess's law gives us room that we can reverse this equation. So let's see if we say we reverse the first reaction. What will happen if we reverse the first reaction? So we'll have carbon monoxide reacting with half of oxygen gas to give us a solid carbon and oxygen gas. Now, when we are applying the knowledge of the enthalpy change, when you reverse the reaction, you also reverse the enthalpy change. So in this case, here the enthalpy change was negative. It simply means the enthalpy change at this point now will become positive. So we'll have positive 110 joules as the enthalpy change of this reaction. After you have this first reaction, you look at what we have as products. So what we have as products is carbon dioxide, which is the product of the second reaction. So this simply suggests to us that we can get the second reaction the way it is. So the second reaction, we are going to maintain the way it is. We have carbon as a solid reacting with oxygen as a gas, producing carbon dioxide, which is a gas. Now, at this point, the enthalpy change of this one is still negative 394 joules because we have not done anything to this equation. After you reach this point, you'll notice that when you want to add equation 1 and 2, some of the reactants and products can simplify. When you look at this solid carbon, can simplify with this solid carbon. This oxygen can simplify with this oxygen. Now, if they simplify, what are we remaining with? We'll remain with this, which is carbon monoxide, which is solid, plus half oxygen, which is in gas, giving us, that is what we have there, carbon dioxide, which is a gas. Now you notice that what we have here is exactly as the question that we have been asked. So if you manage now to have an equation which is exactly as the question that you have been asked, it now guides you to say, add the two enthalpy changes. When you add the two enthalpy changes, you'll get the answer of the enthalpy change of this reaction. Let's get the sum of the enthalpy changes of the two reactions that we have. So what is the sum of 110 plus negative 394? So the enthalpy change that we are getting will be 110 plus negative 394. It should give us negative 284 joules. So this becomes the enthalpy change of the reaction that we have been given.